7 are prime, right? So a little refresher, the prime numbers in a deck would be 2, 3, 5, and 7. Hold on, that comma looks weird. 2, 3, 5, 7. All right, but per suit for each suit. So we're looking at a 2 would have a 2 of hearts, a 2 of diamonds, 2 of spades, 2 of clubs. Same thing for the 3 and the 5. So we got to keep that in mind. But again, we want to decide mutually exclusive or not. So probability of 7 plus probability of prime. That's not a P. And then I would ask myself here, because I'm not overly conclusive, I guess, whether or not I can have a card that is 7 and prime at the same time. Yeah, because I listed out my set of prime numbers, and right there in front of my face, I see a 7. So obviously 7 and prime numbers can happen at the same time. So this is a yes, I want to keep that. So this is not mutually exclusive. Not doesn't need a period at the end of it. All right, so I need the whole shebang here. So I got 4 out of 52 for the 7s. That's a habit now. For the primes, I had 4 cards. Each of these occur 4 times. I just wish I knew what he was yelling about. Because it was like, no! Like, no to what? Can I go to the bathroom? No! Is a sine of 30 equal to 1/2? No! He is, though. Yeah, but it's like funny yelling, right? Yeah, that's the thing. It took a while for me. It took me years to understand that was the case. Like I was like, ooh, kind of scary. He's gonna beat the crap out of me or something. I don't know. But yeah. And he's always been nice to me. He's got a cool truck too. I like his truck. So if each of these numbers occur 4 times, we're talking about 16 total values. Now we just want to focus on, and let me just be clear about this. You don't have to use the formula. I just recommend it. If you're comfortable making adjustments on the fly, you can do that too. But here I would say I would actually do the addition and then subtract off all the cards that are 7 and prime at the same time. And there are 4 of them. All 4 of the 7s. All right. But what people have done in the past, I usually get the question, so I don't want to rob you of the right to ask the question, but they would say things like, well, if I know the 7s are going to get subtracted off anyway, couldn't I just take the set of prime numbers, exclude the 7, and then just add that on? So I'd have the 4 out of 52, and then I would take the prime numbers not including the 7s. Take these 3 values 4 times, so add 12 here and just get my answer that way? Yeah, I don't see why not. It gets you the right answer. You have the right idea. In fact, you have more of a right idea than I think is necessary. So that's a good thing. All right, but we don't all see that. So we go from there. Also, another way to do it would be to say, well, if the 7s are already part of the primes, couldn't I just disregard the separate calculation of the 7s and just account for the primes because the 7s are already in there? Yeah. So any kind of intuition that you bring to it is always going to be a good thing and encouraged. Right? So, but if you're procedural, this is the procedure. Okay? So the primes are evens. So you might be able to apply it right here. So 2, 3, 5, and 7 are our primes again, each occurring 4 times. Our evens are 2, 4, 6, 8, and 10. So if you're doing it intuitively, you might say, well, if I'm putting both of these sets together, I have 2, 3, 5, 7, 2, 4, 6, 8, and 10. Well, I don't need the 2s to have in a second time. So let me just do 2, 3, 5, 7, 4, 6, 8, and 10. Only count the unique values. Perfectly fine, but I'm going to use the formula approach. So, and by the way, because the 2 is in both sets, we know that it's not mutually exclusive. I don't even have to write the formula out to know that. Just by looking at the numbers themselves, I'm able to determine that information. So probability of a prime number plus the probability of an even number minus the probability of prime and even. So the primes, we know that there's 16 of those out of 52. Each one of these numbers here are going to occur 4 times a pop. So there's a total of 20 of those values. So the only number that's both prime and even is the number 2, and that occurs 4 times in a deck. So 32 out of 52. It should be. Yeah, it's going. All right, so formulaically we can do it. It just seems redundant, though. But redundancy is good if it gets you the right answer, right? And also, a general rule is very tech friendly. Like if you want to apply this to computer software, even a calculator program or something, it's more likely to work if you leave it in its most general form than it would if you try to use intuition. Because computers, they're not very good with intuition, but they are good with explicitly stated procedural steps, like what we're doing here. But you might look at this and say, why don't I have to do this? I can just account for it right here. That's fine. I'm not telling you have to do it this way. Answer, reasonable justification. All right. Some people will draw out a big old Venn diagram with lots of arrows, numbers inside the arrows, and have the right answer. That's wonderful. I actually, before I got to a point where I needed to give the sample space for a deck of cards, I would have people, as in showing their work, draw the entire deck of cards and then circle the relevant ones and then put the answer. That was the only question that they had left at the end of the test. They didn't know how to do it using a formula, and they had like 30 minutes on their hands. So they were like, you know what? I'm just going to do it. I'll get the right answer. I need the work, so I'm just going to do it. And they did it. And that was perfectly fine. All right, some kind of reasonable justification. Now, D, sometimes tuition is like a luxury, and sometimes it's necessary, and sometimes you hit that gray area where it's like, it could be a good thing, but it's not totally necessary. In this case, you could survive if you don't make the adjustment, but it is nice if you do, because if I think of this as 7 or black, because in a deck of cards, it is pretty cut and dry. If your card is not red, it's black. If your card is not black, it's red. So we could make that jump. Now, since the number of red equals the number of black in the deck of cards, 26 red, 26 black, you also have an equal number of red 7s and black 7s, 2 and 2. I could change this problem. So this would be the same as probability of 7 or red based on that symmetry, which I already know is 28 out of 52 from the previous page. All right, by making that little leap, I took a problem that would have required a little bit of work and made it into a problem that required minimal work. All I had to do is state this relationship and I have my answer. Right? Because if I played it out, it would be probability of 7 plus the probability of black minus the probability of 7 and black. So it's the same exact calculation as on the previous page. So it's asked and answered. You know, it's you do a problem often enough, like factoring x squared minus 4. It's x plus 2x minus 2. Why? Because of factoring rules? No. It's x plus 2x minus 2 because you've seen it 1,000 times before, and that's just what it is. You know, like maybe the first couple of times you needed to understand why it was working. After a certain point, it was like, no, that's just what the answer is. You know, so, and that's what the case is here. If you recognize that this is the same as another problem, you can use that information, and that's good for you.